This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we're diving into a fascinating interactive learning tool, the JavaScript simulation applet designed to model high power transmission lines. It's part of a larger collection of open educational resources.
Indeed. These simulations offer a powerful way to visualize complex concepts that are otherwise difficult to grasp through traditional methods.
Exactly. The visual aspect is key, isn't it? It's one thing to read about electricity transmission, but quite another to see it simulated in real time.
Absolutely. The ability to manipulate variables and observe the immediate effects is invaluable for understanding the underlying principles.
And this particular applet focusing on high power transmission lines seems particularly relevant given the increasing importance of efficient energy distribution. Let's start with the core purpose of this applet. What does it aim to teach students?
Primarily, it aims to illustrate the challenges and complexities involved in transmitting electricity over long distances at high power. Students can explore factors like voltage, current, resistance, and power loss.
So it's not just about the basic principles of electricity, but also the practical considerations of large-scale power grids?
Precisely. It allows students to experiment with different parameters and see how they affect efficiency and stability. For example, they can adjust the voltage and observe the impact on power loss.
The applet is described as interactive. Can you elaborate on the ways students can interact with it?
The interactivity is a key strength. Students can adjust various parameters such as the length of the transmission line, the voltage, and the load. They can then observe the changes in current, power, and power loss in real time. It's a hands-on learning experience.
That's engaging. Does the applet provide any feedback or guidance to the user?
While the primary focus is on exploration, the visual representation itself provides immediate feedback. Changes in parameters are instantly reflected in the simulation, allowing students to draw their own conclusions.
The applet is built using JavaScript and HTML5. What are the advantages of this approach?
HTML5 and JavaScript make the applet highly accessible. It runs directly in a web browser, eliminating the need for specialized software or plugins. This broadens its reach significantly.
And the embed code provided suggests it can be easily integrated into other websites or learning platforms.
Exactly. The iframe code makes it simple to incorporate the simulation into existing educational resources, enhancing their interactivity.
What are some of the key learning outcomes students can achieve by using this applet?
Students gain a deeper understanding of the principles of electricity transmission, the factors affecting efficiency, and the challenges of managing high-power grids. It bridges the gap between theoretical knowledge and practical application.
Does it cater to a specific age group or educational level?
While adaptable, it's likely most suitable for secondary school or undergraduate students studying physics or electrical engineering. The complexity of the concepts requires a certain level of prior knowledge.
How does this applet compare to other available resources for learning about power transmission?
Many resources exist, but this applet offers a unique combination of interactivity and visual clarity. Traditional textbooks or lectures often lack the hands-on experience this simulation provides.
So the interactivity is a key differentiator?
Absolutely. It allows for experimentation and exploration in a way that static resources simply cannot match.
Are there any potential areas for improvement or future development of this applet?
Adding more advanced features, such as modeling different types of transmission lines or incorporating real-world data, could enhance its educational value.
Perhaps incorporating elements of renewable energy sources into the simulation?
That's an excellent suggestion. Integrating renewable energy sources would make the simulation even more relevant to current energy challenges.
This applet is part of a larger collection of open educational resources. What's the significance of this open access approach?
Open access democratizes education. It makes high-quality learning resources available to a wider audience regardless of their geographical location or financial constraints.
And it fosters collaboration and community development within the educational sphere.
Precisely. Open resources encourage collaboration among educators and developers, leading to continuous improvement and innovation.
Are there any common misconceptions about high-power transmission that this applet might help to address?
Yes, many students struggle to grasp the concept of power loss over long distances. The simulation allows them to directly observe this loss and understand its dependence on various factors.
And the importance of high voltage in minimizing these losses?
Exactly. The simulation visually demonstrates why high voltage is crucial for efficient long-distance transmission.
How could educators best integrate this applet into their teaching?
It could be used as a pre-lab activity to introduce concepts, a post-lab activity to reinforce learning, or even as a standalone learning module.
And the potential for student-led exploration and discovery?
The applet's interactive nature encourages student-led exploration, fostering critical thinking and problem-solving skills.
What is the overall role of simulations like this in STEM education?
Simulations provide a safe and engaging environment for students to explore complex concepts and develop a deeper understanding of scientific principles. They bridge the gap between theory and practice.
And they can make abstract concepts more tangible and relatable for students.
Absolutely. Visualizing abstract concepts through interactive simulations significantly enhances learning and retention.
The article mentions the applet is created using easy JavaScript simulations, EJS. What are the benefits of using such a framework?
EJS simplifies the development process, allowing educators to create interactive simulations without needing extensive programming expertise. It focuses on pedagogical design rather than complex coding.
The article also highlights the applet's embeddability. How does this feature enhance its usability?
The ability to embed the applet directly into learning management systems or websites makes it seamlessly integrated into existing educational workflows. It avoids the need for separate access points or downloads. In conclusion, this high-power transmission line simulator is a valuable tool for enhancing STEM education, offering a unique blend of interactivity, accessibility, and pedagogical design.
That was a great discussion. Thank you for sharing your expertise.